to increase the speed of that fire and how that fire will develop. You'd see now they provided a lot of air. We started seeing that fire come out of that compartment. As he shut that down, you can clearly see a neutral plane. You can see the bidirectional flow, and you'll begin to start seeing that smoke almost puff and get turbulent as it comes out of that compartment, because that fire that's burning is just looking for more air. It's looking for air, so it's trying to pull all the available air into that compartment. This is the same as we have in our house fires. Now you can see the smoke is a little bit darker and denser. You can clearly see a neutral plane and some bidirectional flow. And we started to have a little bit of fire coming out of that compartment. Now, as if he opens up that compartment just a crack at this point, you'll see that smoke start to push, and you'll see the bidirectional flow and that air being drawn into that compartment. As he opens up that compartment more, we're providing more air, so we're gonna have a greater fire. What we have to remember is in our fire tactics, whatever we're doing on the building is creating a hole, which is ventilation. Whether we're fire attack, we're forcing entry, we're search, or whether a door fails or a window fails, that's providing ventilation. In the past, our ventilation was, we thought of just breaking a window or just cutting a hole in the roof. And what happened here is he closed down that compartment. He limited the oxygen into that compartment and actually snuffed the fire out. It's the same thing we like to talk about during our fire prevention and education is when there's an oven fire. We tell our occupants what? Shut the oven door and the fire will go out. We just did the same thing here in a wood structure. We just controlled the amount of air and we actually choked that fire out. So just by controlling the openings affects the fire behavior. So at this point in the drill, you want to let this compartment get going again. You want to really start heating that OSB up. And shortly we're going to open up compartment 3 and we're going to remove the door that goes from 4, which is lower right, to 3 to the lower right. So you see we opened up 3, but we don't have a lot of smoke pushing out of there. But now as he opens up the door between the lower right and lower left, you're going to see a change in the fire behavior. You're going to see this lower left become an outlet only. When we say outlet, that's just where the fire is exhausting out of that compartment. You don't see a lot of air, you don't see a lot of bidirectional flow or a neutral plane. If you take a look at compartment 3, that compartment you have some bidirectional flow. You have an exhaust port, but also in the lower part of that compartment, you see the intake or the inlet of the fresh air. That's traveling across to the lower left compartment to feed that fire. If we were to shut down compartment 3 completely and lower left, we could again choke this fire out just by limiting the amount of air. And as he closes this compartment and we shut down lower left and he opens that up just a little bit, you're going to start seeing that smoke puff and you see it really starving and looking for that air source. So we're going to open up lower left a little bit more. Give it the air that it needs. As you can see, very little air allowed that compartment to almost flash over, like a ventilation-induced flashover. So we're going to open up lower left and get that compartment going again. And we can open up 3. Now close down lower left. Strictly by controlling where the fire is getting its air source from, we can control where the fire goes to. So we can control our buildings by playing with the openings. You see over here in the lower left, he's just opening and closing that compartment, and we're clearly showing you a neutral plane there, some bidirectional flow. And you're going to see those gases, or the smoke, the unburned products of combustion, that fuel, start lighting off. Now remember, there's no fuel in lower right. That is strictly the smoke. That's the gases that's beginning to flame over and ignite in the lower right-hand compartment. You'd see lower left is still burning. We have plenty of heat in that compartment. And now over to the right, we're getting the heat, the fuel, and the oxygen that we need to have ignition. You'll also notice if you look up towards the top or the ridge line of this house, you start having increased smoke production at multiple levels or multiple floors to this house. The same way you would with a standard 2-story wood frame private dwelling. You're going to start having smoke migrate through the entire house along with the heat and decreasing the amount of oxygen on all levels of the house. When you do this drill, it's always good to have a water sprayer from a garden hose or a 2.5 can pressurized water extinguisher available, because you want this drill to go on as long as you can. So if you keep wetting the exterior of the box, you can keep that compartment and that box intact as much as you can. And what you see now, the partners, they're just controlling the openings, allowing air in or allowing air out. And we saw a little ventilation-induced flash over there. See compartment 3, we have the smoke is a lot darker, it's a lot denser, so we're creating a lot more heat within this box. So now he's going to close up 3, and we're going to start moving up to the 2nd floor, and we're going to open up number 2. Now see, as he opens that, we have some decent smoke, and we have that bidirectional flow, and you're going to see the building start really pushing and pulling and really looking for more oxygen. And he's going to reach in and he's going to remove the hole in the floor that's simulating a door, and you're going to see things change a little bit. What we're going to do is we're going to actually draw the fire up into that compartment, because what's the fire always going to do? It's going to travel to the source of oxygen. And you just clearly saw that we just had a little phenomena there where it grabbed the oxygen and it flashed a little bit. And standing here, you can actually almost feel a little pressure wave. So we can start showing the differences or talking differences between flashover and backdraft. As we close the lower left compartment, we'll start seeing that we have fire that has moved all the way up into the top right. Here's your water sprayer if you want it for the outside of that compartment if necessary. So now we have good fire going in the entire bottom left compartment that's migrated to the bottom right. And now you're starting to see an increase of heat. You're starting to see that smoke become a little bit more turbulent, a little bit darker. We still can clearly see a neutral plane there. We have that bidirectional flow. If he opens up number 2 just a crack at this point, which is the bottom left, we're going to open up bottom left, you're going to see a change in that opening. You're going to see the smoke increase of speed. So now watch as he closes the lower left. We'll see the smoke is still present, but the smoke slows because it doesn't have an oxygen source below that level. As he opens up the bottom left, you're going to see that smoke increase in pressure, increase in velocity, and it's also increasing in heat. So that would be similar to a 2-story house if the window lets go, or you perform horizontal ventilation on the floor above a fire. As we keep playing with these openings, those gases will ignite. The more air, the hotter the fire gets. For a long time, we were always taught that ventilation equals cooling. Ventilation doesn't equal cooling, water equals cooling. So ventilation will increase your heat release rates and it will increase your opportunity or chances of flashover or backdraft without water application. So you see, the more air or less air that they provide to this box really changes the fire behavior. So as you see, as we supply more air into this environment, we're increasing the temperatures, we're increasing the products of unburned combustion, which is more fuel, and the fire is lighting off in the smoke. As you'll see, as he opens up bottom left again, we're going to see the smoke in the top right begin to light off. And that's just because we're increasing the heat. Even though we're ventilating, we're increasing the heat, and that smoke will begin lighting off. As you see, we're providing a lot of air below the fire and also above the fire, so it's getting really turbulent, it's getting very dense, and you can see that upper right doesn't have a neutral plane. That's strictly an outlet. Your inlet is your bottom left. You can see the smoke and the heat getting drawn right in there. Now we can shut those down. We can cool the outside of the box with the water. What I want to do is I want to simulate roof operations. So in the small-scale fire behavior prop, we also want to show the positive and negative effects of roof ventilation. We have 2 slide trays 2 slide trays built into this prop. We have one at the roof or at the peak, so now we can open that up, and it shows what performing roof ventilation or cutting the hole in the roof actually does. But the important note to our students is that just cutting the hole in the roof isn't enough. We always need to push down and break down the sheetrock. And so we have another slide tray that we're going to open now to simulate breaking open the sheetrock. And as we do that, you can see the velocity and density of the smoke increase. And without water application, we will have fire that comes out of this roof. This is an important point to show to our students that vertical ventilation is possible.